Today we're going to use segment addition postulate and algebra to find missing pieces of a segment. Our problem says if EG equals 71, find the value of X. So using segment addition postulate, we're going to add parts of a segment to equal the whole segment. So the first thing we're going to do is we're going to write down our equation EF plus, which is the first part of the segment, FG, second part of the segment, equals the entire segment, EG. Next, what we're going to do is we're going to substitute our information into our equation. According to the diagram, EF is 8x subtract 17 plus, diagram says that FG is 5x minus 3 equals, and the given information says EG is equal to 71. At this point, it becomes an equation. So now we're going to combine our like terms. 8x plus 5x is 13x. Minus 17, subtract 3 is minus 20, equals 71. Then we're going to add 20 to both sides. We get 13x equals 91. Then we're going to divide by 13 on both sides. We get x equals 7. Before we conclude this as our final answer, we go back to our original problem, and it says find the value of x, which we have done. And so our final answer here is x equals 7. Okay, so now for example 2. Example 2 says if TV equals 14x minus 8, find the value of TU. So again, we're going to use segment addition postulate here. I'm going to write our equation first. TU plus UV equals TV. TU, which is the first part of the segment, plus UV, the second part of the segment, equals the entire segment TV. Always get in the habit of writing down that that part of the equation first so that you will substitute information into the right spot. So now we're going to substitute. TU is 9x plus 2 plus UV is 5 equals our given information TV, 14x minus 8. Now we're going to combine our like terms. On the left-hand side, we got 9x plus 7 equals 14x subtract 8. Now we're going to move our variable to one side. I'm going to move 9x. So I'm going to subtract 9x on both sides. Get 7 equals 5x subtract 8. Two-step equation. So now I'm going to add 8 to both sides. 15 equals 5x. I'm going to divide by 5. 3 is equal to x. Now, before we conclude with our problem, we go back to the original statement, and it says find TU. So in order to find TU, we have to use x and substitute back into TU. So TU is equal to 9x plus 2. So then we're going to substitute our x that we just found, 3. So 9 times 3 plus 2. 27 plus 2. TU is 29. And that is our final answer. For example 3. Example 3 says if JL equals 5x plus 2, find JL. So again, we're using segment addition postulate. I'm going to write down our equation first. Always get in the habit of writing that down first. So we're going to say JK First part of the segment plus KL, second part of the segment, equals the entire segment JL. Then we're going to substitute our information. JK is 27 plus KL is 3x subtract 1 equals JL, which is 5x plus 2. Now we're going to combine our like terms on the left-hand side. We're going to get 3x, and then 27 subtract 1 is 26 equals 5x plus 2. I'm going to move my variable. You can move either 5x or 3x. I'm going to move 3x. So I'll subtract 3x on both sides. You get 26 equals 2x plus 2. Subtract 2 on both sides. You get 24 equals 2x. Divide by 2. And 12 is equal to x. Before we conclude, let's go back to our original problem, and it says find JL. So now we have to use our x to find JL. So JL, in this case, according to segment addition postulate, is JK plus KL. So we got to substitute JK and KL's information in to get JL. So JK was 27 plus KL was 3x subtract 1. So now we're going to substitute in 27 plus 3 times 12 subtract 1. 27 plus 36 subtract 1. 63, which is 27 plus 36 subtract 1. And our answer is 62 for JL. And that concludes our third example on using segment addition postulate and algebra.